Hello dan Assalamualaikum. My name is Ahmad Afzal bin Aminazul Nizam. My matric number is 01DE24F1142. Now I'm gonna explain about bipolar junction transistor, which is BJT. So, bipolar junction transistor BJT has 3 dope semiconductor regions separated by 2 PN junction. The 3 regions are called emitter, base and collector. Transistor can be either PNP or NPN type. The base region is lightly doped and very thin compared to the highly doped emitter and moderately doped collector region. Current does not flow in through the emitter and collector unless there is voltage bias applied to the base. So for the objectives, at the end of the lab session, students should be able to sketch the symbol of transistor using the multimeter ohm range to check and identify the transistor electrode terminals, the NPN or PNP type of bipolar transistor, the silicon or germanium type of bipolar transistor. Next, to identify the terminals of a bipolar transistor from its physical shape. Alright, so there are 3 types of a BJT, which is base, collector and emitter. So base is to controls the transistor. A small current here controls a larger current between collector and emitter. Next is collector. Collector carries electron of holes from the base and emits them toward the external circuit. Next is emitter. Emitter carries into the base region, provides the majority of current flow. So to identify the base terminal, the multimeter need to be reversed, which is red probe to the negative and black probe to the positive. So select the ohm range between 10 ohm or 100 ohm. Now, the red probe and black probe didn't touch the terminal 2. Either red probe to the terminal 1 or terminal 3 and black probe to terminal 1 and terminal 3. It shows there is no reading, which is infinity. So that is not a terminal base. Now, red probe at the second terminal and black probe either terminal 1 and 3, which is shown a value that it's the base terminal. So there are 2 main types of bipolar junction transistors, which is NPN and PNP. So an NPN transistor has a layer of positive p-type material between 2 layers of negative n-type material. A PNP transistor has a layer of negative n-type material between 2 layers of positive p-type material. In an NPN, the current flows from collector to emitter and base current enters the base. In a PNP, the current flows from emitter to collector and base current exits the base. The biasing technique is to operate the transistor properly. The 2 PN junction must be correctly biased with external DC voltage. I will demonstrate either it's NPN or PNP. Put red probe to the base. If they are shown value, it is NPN. And if you reverse the probe, it will show that it is infinity. Why silicon is more used than germanium in BJTs? So first is thermal stability. Silicon can handle higher temperatures before it starts to break down. Germanium transistors start leaking current at relatively low temperatures like 70 Celsius, but silicon transistors can work well up to around 150 Celsius or even higher. This makes silicon devices much more reliable for real-world electronics, especially where circuits can heat up. Next is lower leakage current. Silicon transistors have much lower leakage currents, unwanted tiny currents when the device should be off, compared to germanium. This makes circuit more efficient and stable, especially at higher temperatures.